Now, Flutterflow recently released a bunch of new features, but really the biggest one of them all is the ability to do streaming API calls. And this is an amazing feature that allows you to have that kind of ChatGPT behavior with all kinds of APIs. And so in today's video, I'm going to be explaining to you why this feature is so important. I'm going to be showing to you how you can leverage this feature, and then we're going to take a look at my proof of concept app so that you can learn how to implement this feature yourself. First of all, why is this feature so important? Well, if you've used ChatGPT before or other similar products, you're probably familiar with that streaming answer functionality where you ask a question and instead of dumping an entire answer after 10, 20 or more seconds, it starts responding immediately and answering your question word by word as it starts to figure out what you're looking for. And that is called a streaming behavior. And so in my opinion, and in probably your opinion as well, this is a much better user experience than the alternative where the user is going to be getting an answer after the system figures it out. And that might take a long time while the user is waiting and wondering if the system is going to deliver an answer for them. And so this way, the user knows that the system has an answer, so they can simply wait until the streaming behavior is completely finished. Now, the problem here is before we had this functionality in Flutterflow, you could not implement this feature. So even though your APIs, things like ChatGPT or other LLMs or other APIs, may have supported this streaming functionality, there was really no other way. There was really no way to implement this in Flutterflow. And so you had to create your own custom code. You had to create a custom action, which is something that I did in one of the previous videos to demonstrate to you guys how you can implement this functionality when you do not have native API support. But right now you have that native API support, which means that you can choose between implementing a standard non-streaming API behavior or a streaming API behavior. Now, before I show you a working proof of concept that further demonstrates how you can do this with Flutterflow, let me show you a diagram that best explains how this feature works. So right here, you're looking at a standard diagram that showcases the standard, which is the non-streaming API behavior. So we have the user here, we have the UI, we have the logic, and we have the backend. And so all these three pieces is your app, right? So the user is interacting with the UI, there's the logic behind the scenes, and then you're saving or reading the data from a backend. And so in a typical API call, which is this module right here, you're going to be connecting to a remote server and you're going to be sending some kind of a request. And this request could be as simple as getting some data, or it could be a little bit more complex where you're saving some data. And it's important to understand that all this time while the server is doing its work, this system here, right, your API call is waiting, right? It's synchronous, okay? So until this finishes, nothing else can happen. You cannot go to the next step until this is done, because the system knows that at some point in time, it's going to respond with a full response, whether the request was successful or if the data that it's looking for is ready. And so the system is not going to do anything until it gets that full response. Now, on the other hand, if you take a look at a situation where we can make an API call and we have the streaming support, it's going to behave slightly different. So this first row here is exactly the same, but where the big change is how the API call is going to behave. Okay, so we have our API call, we send the request, which works exactly the same way as before. But the difference here is in the response. Okay, so the system is going to call a callback, which means it's going to be letting us know if it has some data, and it's going to be doing it in an asynchronous way. And so in this case, the API system is going to make a request, and then it can just do something else. It's not going to be waiting for a response in a synchronous way where it's blocking the system and blocking the user from attempting to do anything else. And that is because the way that this is going to work is that as the data is going to be coming in, this system is going to get notified in a callback style. Okay, so what it means essentially is that it sends a request and then it forgets about it. But at some point in time, maybe 5 seconds later, or maybe 50 seconds later, or an hour later, it's going to be awakened with some data, right, via a callback. And so this callback can be one of three of these conditions, right? It can either be data that's coming in, it can be an error, or it can be a finishing message, which means that there is no more data coming in. We can close this off and do something else. And so while this is processing, your app can do just about anything that it wants to do because it knows that it will always be getting this data and it will be able to do something once it gets this data. And so that is how this streaming API call system works in a nutshell. Okay. And so, like I said in the beginning of the video, this is something that was not supported by Flutterflow, right? This is something that you had to do using custom code. And that is why in some of the previous apps, I built custom actions that did just that. But right now we have a way to configure our API calls to support streaming. All right, so now that I've shown you an architecture diagram just to explain to you guys how it works behind the scenes, let me show you a working proof of concept app that I built that shows you the standard API response behavior as well as the streaming API response behavior. And then we're going to jump back into the app and I'll show you exactly what you need to do. And remember, guys, if you're a member of our amazing Patreon community, you'll be able to view and or clone this app right away, which means you don't have to worry about any of this. You can simply add this app to your own library so that you can build on top of it, so that you can learn how it works, and you're going to be getting a ton more value as opposed to just viewing this app on your screen right now. And so let me go ahead and run this app so that you can see how it behaves. All right, so here's our app, and this app has two pages. So the first is the standard behavior, and the second is the streaming behavior. Now, I'm actually using Claude 3.5 Sonnet LLM for this demonstration, but you can use pretty much any LLM. They all work pretty much the same, including ChatGPT or any other LLM. They all work very, very similarly, if not exactly the same. And so if we come here, and let's say I ask the LLM, hey, how are you? And we hit send, we see the message, but we have to wait until the whole response is done. So there's no streaming here. If I say something like list 10 cities in the US, we need to wait, right? There is a delay as it's thinking, okay? And then it comes up with the entire answer here. On the other hand, if we come to this second page, and this is the streaming behavior, we still see this conversation here, but the responses from now on are going to be in a streaming format. Okay, so for instance, let's say we ask it, list 10 biggest cities in the world. Okay, we hit send, and now it's thinking and it's coming up with the answers immediately. Okay, so the user doesn't need to sit around and wait for the whole answer in one shot, right? They can be sitting there and seeing this system come up with an answer word by word, token by token. So let's say I ask it something else. List 25 capitals around the world. Okay, so this means it needs to come up with a lot of data, and streaming is going to work really nice. So you see, it's coming up, and this is the response that it came up with. Whereas if I come in here and I say list 30 random cities, it's gonna think for a minute, right? It's gonna think for some time, right? It's still thinking. Okay, and now it has this entire list, right? And so in my opinion, this is something that I talked about before. Streaming is a lot better. It's a lot more fun. It's also a lot more user friendly. And so this is definitely the recommended method going forward. All right, so let's jump back into Flutterflow and I can show you exactly how this new feature works, okay? The first thing that you need to do when you're setting up your API call, you need to do two things. First, you need to send something like I have here. So with this API, we need to say stream equals to true, right? We need to tell the system to stream the response back to us, okay? Otherwise, if we don't do that, it's not gonna know, right? So it's gonna default to the standard behavior. So that is the first thing that we need to do. The second thing that we need to do, if you head over to advanced settings, you want to make sure that you enable this, right? Process streaming response needs to be turned on, right? So I have it turned off in the first API call, right? I have it turned off. And then the body, I'm not saying streaming is true, right? I'm not saying that, right? Because that's the standard behavior. Whereas here, I have it turned on and I have this set here, okay? Now, once you do that, you're going to be getting different responses. So if we come to response and test here, and this is my standard response, and I do test API call, you're going to see this. But if you click on raw body, you're going to be seeing a bunch of responses. Now, this here is a scrollable list. Okay, it may not seem this way because you might not see a scroll bar right away, but you can scroll down. And what you're looking at here is the tokens that the system is sending one after another. And so when you send a streaming request, you're going to be getting back these tokens. Okay, so you need to parse the data that's in these tokens and display it. Okay, so if we take a look at the first token and you scroll down all the way to the right, you're going to see that there's no data here, right? It's just a token. But if you go to the second one, you see that text is empty. Here, there's nothing here. If you come over here, you see text says hello. If you come over here, it says how. And then if you scroll down, we see how can, right? So it's going to say something like, how can I help you? Because I said something like, you scroll further, it says, I assist you today, right? And so we're getting piece by piece answer here, right? Because the request I sent was hello world. And so first it says how, then it says can. And if we go to the next chunk here, it says feel. And then if we go next one, feel free to ask me. And then if we keep going, it says any, right? So these are all chunks. We're getting piece by piece answers. And so what we need to do now is we need to take these chunks here, parse them, and display them in a way that the user will understand, right? In that kind of streaming behavior here, okay? And so the first thing that I decided to do here is I decided to create a custom chunk type, okay? And so it says here, parse each chunk as a data type, right? So if you go over here, I have this custom response type, all of this, and then, you know, this thing is a data, which is delta, and then you have delta here. And so the easy way to create it is by simply going back to your API call here, coming in here, doing this test API call. Actually, for this one, you want to do that. You want to do it for this one. And this is my tip to you, is that what you can do is you can simply copy this data here, copy it, go back here, and you can click here and you can paste it here. And then you can call this. You can say, well, this is my response type. Okay, and then create. I already did that, and that is why you're seeing this here. And that essentially takes that JSON response and breaks it apart. Okay, and this is great because now we can parse the responses into this data structure, and that's going to be very, very helpful to us later. Okay, next, let's go back to the app. So I have a very kind of standard chat app, and I've done many of these chat apps before. So if you've seen my previous videos, you know exactly the structure here, okay? So before I show you the chat app, if we head over to app state, you can see that I have a list of messages, which is a message type, and this message type has just 3 fields. The role, which is going to be either user, which is me or you, or the assistant, which is the LLM AI. Then we have the message and we have the timestamp here, okay? And this allows us to store the messages with, you know, knowing who is the sender and when the message was sent, okay? And so if we go to our app state, I have these messages, a list of messages here. Next, we have here the main part of the screen, and that here is a list of different rows that have a stack as the parent, and that allows us to display rows in kind of this alternate style. So either it's going to be, you know, my message or somebody else's message. We're never going to have 2 messages at the same time, right? Because we're going to have one row with my message, another row with somebody else's message, right? And so so we're never gonna have it this way. It's gonna be either, maybe a message here, or message here, message here, message here, and then another message. You're never gonna have two messages on the same row because we also have conditional visibility. So this row here is only going to be displayed if this is a message sent by the AI, whereas this row is only going to be displayed if this is a message sent by the user. Now, if we select the button here, if you open up this right here, you're going to be seeing three actions here. So the first thing we're doing is we're adding the message that the user sent to our list of messages, right? I say add to the list, and I give it a role of user, okay? The second thing we're doing is we're creating another message that the AI might have sent, all right? And this message is just gonna say thinking, right? So I'm creating another message and I'm saying thinking. And that way, once the user sends a message, we immediately get a response that says thinking, right? And then when we get the real message from the AI, we remove that thinking message and we display the actual AI message. Now, the key point here is that in this API call, right, we select this API streaming, and because this thing supports streaming, we have three callbacks that we can now utilize, which was not the case before, right? So with a standard API, you don't have any callbacks, right? Because you execute it and you just display a result, right? So if I go back to my regular call here, and I open it up, this is what it looks like. This is a regular API call. I call it. If it succeeded, this is going to happen. If it's not succeeded, we're going to display some kind of an error message, right? This is a synchronous behavior, right? This just goes from here to here. Whereas in a streaming behavior, right, if you come over here, we don't have anything here, right? That is because it's all happening here, right? So the first callback is the on message, or once we get a message. The second callback is on error. If you get an error, do something. And the third and last callback is on close, right? When we are done, when it finishes sending stuff. Maybe we want to, take some action based on that. Right here, I am only using this first callback on message. And so if we click here, we now have another action flow that is executed, or when we get a message, right? And when I say a message, it's a chunk, when we get that individual chunk. Well, remember when you saw those multiple chunks in a sample API request? Well, every time we get a chunk, this whole thing gets executed. Now, this first half here, right, what we're doing here is we are keeping track of how many chunks we have so far, because if it's a first chunk, which means that, this is the first chunk that we're getting, right? We don't have any data. We didn't have any data before that. We need to remove this message, right? So what I'm doing is I am removing that thinking and I'm replacing it by an empty string here, okay? Next, this part is the key here, because what I'm doing here is I'm checking whether the response chunk has the text field. Because if you remember in that sample API call, we had a lot of chunks, but they were, some of them were different, right? And that will happen. They're not going to be all the same, right? They may be slightly different. They may be radically different. And so it's very, very important for us to first check whether this chunk has actual text, because it might have something else, okay? Or it may not even have text, okay? So we need to make sure that we have this. And so here, what I'm doing is I'm getting this chunk, right? This action parameter, right? So if I go over here, I have this action parameter, which is the message input. And remember, we are parsing it as that message type. And so we're parsing that JSON, breaking it up into different fields according to what we have as that data type there, right? And so what I'm doing here is I'm checking whether it has this text field there, right? Because if it does, then we have data coming in. We have actual text data. If it doesn't, we don't really care about it, right? It might have something else. It's not very important. And so if it does have it, we are going to be updating that message, right? We're not going to be creating new messages, right? Because otherwise we're going to have multiple messages as chunks. We need to update that specific message. And which message? Well, the last message. Okay, so remember, for the first message over here, very first message, we create a message here. And so regardless of what happens, there's going to be at least one message, right? Typically, you're going to have a lot more than one message. But at the very least, you're going to have at least one message, right? So if you jump back over here, what we are doing here is if we have the text, we're going to be updating that message by appending this new message to it, right? So what I'm doing is I'm doing a text combination, and I'm getting that original text and I'm appending a streaming response, which is that actual text that we're getting back from the API call. On the other hand, if we do not have any text coming in, I just have a dummy action that doesn't really do anything, right? So we have a text combination, it just returns the message. So it's basically, it sets the message to itself. And last but not least, we're going to clear that bottom input. So the user does not need to clear it when sending a new query. And then as a result, we execute the API call. But when we do that, the system is not going to be blocking, right? So over here, if we come over here, if we execute an API call and we say something like, list 20 random cities here, when we click send, the system is going to block because it's waiting for the response. And when I say block, it's not going to be allowing the user to do anything else, right? So you see how it's waiting here, right? It's blocking because it's waiting for the response. And now it has a response. Whereas here, if I say, give me top 25 cities, it just sends it right away, right? It doesn't block. It gets a response, it sends it, but it's not going to be blocking while it's getting the response because it does it using callbacks, right? It does it asynchronously. And so as a result, we don't need to worry about what we need to do after the API call. All of that is taken care of for us via callbacks, right? So it's a different behavior. And because here we're displaying a list of messages, and here we are updating the messages, the individual message, the last message that needs to be displayed, we are getting that beautiful streaming behavior. And you have to make sure that when you're updating this app state, right, when you're appending the messages, you need to have this rebuild current page, because if you set no rebuild, you're not going to be seeing that streaming behavior. And so all of this is going to be for nothing because you're not going to be rebuilding that widget. You're not going to be rebuilding that page when you're updating the app state. So this is very, very important. And thankfully, by default, this is going to be set. But just in case, so that you have to make sure that you're rebuilding this current page. And as a result, we have this beautiful streaming behavior functionality without needing to resort to creating custom actions, which is something that I had to do in previous videos. So this is a great, great feature. And even though here I'm showing it to you with Claude 3.5 Sonnet, this is going to work with all kinds of API calls, even non-LLM. There's lots and lots of cool API calls that give you the streaming functionality, and now you can leverage it in your Flutterflow apps. Now, earlier in the video, I mentioned that you're going to be getting access to this app when you join our amazing Patreon community. And really, it's a great, great benefit because this app is done for you, right? You don't have to worry about anything. All you need to do is enter your API key right here. You can simply use OpenAI system. They use almost the same API format, if not the same, exactly the same. All you need to do is replace your API key, replace the URL, and you can get this app to work with ChatGPT as well. And so this is cutting edge functionality, right? It was just recently released, and you can start building apps to take advantage of it without needing to do any custom code, right? And that's the beauty of no code, right? It's to give you the features, the functionality, the resources, so that you can go out and build the app that you want to build without getting bogged down with code. And so as a member of our amazing Patreon community, you'll be able to view and or clone this app. Plus, you're going to get access to all my apps, including lots of complex apps, lots of different niche apps, lots of different apps that showcase all kinds of cutting edge features. Plus, you're going to be getting access to our extra content, such as Q&As, live streams, behind the scenes content, as well as our Patreon supported masterclass series, where I do deep dives of different topics, apps, and tools. It's all on there. In fact, just a couple of days ago, I did a huge complex app that was more than 5 hours long, and that entire app is on there. And so if you're looking to build a complex app, I have lots and lots of complex apps. I believe I have over 170 or maybe even more apps at this point, because every single app that I bit as part of a tutorial on the channel is on there, right? So you'll be able to get access to all my apps, extra content, and you're going to be supporting this channel and supporting my work. So if you're getting value from these tutorials, then you're going to get even more value inside of our amazing Patreon community. And so if all of this sounds good to you, check out the first link in the description below the video and become a member.